What if we're the aliens of this planet? Are we the original inhabitants of this world, or did we come from somewhere else? Scientists have wondered for a long time how life originated on Earth. One possible answer to this age-old question is the theory of panspermia. Panspermia is a hypothesis that suggests life on Earth originated elsewhere and was transferred to Earth through comets, asteroids, planetoids, or meteorites. The origin of life was first questioned back in 500 BC by Greek philosophers Anaxagoras and Socrates. In the late 1800s, William Thomson, a mathematician, physicist, and engineer, proposed, since meteorites came from space, perhaps they carried life with them. Later on, Swedish scientist Arrhenius concluded that life could migrate through space and proceeded to name this theory panspermia. According to panspermia, living organisms could have been transported on purpose or unintentionally. Professor Francis Crick, one of the biologists who discovered the DNA structure, and British chemist Leslie Orgel, explored the idea that life on this planet was sent by an alien civilization facing possible extinction. This theory is what we call directed panspermia. Although a possibility, the scientific evidence that has been collected so far is not enough to prove such an extreme idea. But that doesn't stop us from attempting to prove that this is a viable option for spreading life throughout the universe. In fact, scientists have done experiments where they expose bacteria to simulated conditions here on Earth, and have even attached samples of bacteria to the exterior of spacecrafts and satellites to test their capability to survive in outer space. Life forms that can survive the harsh conditions of space are called extremophiles, and have the ability to remain dormant for a specific amount of time. In 2015, an experiment done at the University of Kent tested these bacteria to examine their ability to survive shock pressure experienced during impact and their size and pressure independence within oceanic and rocky impacts. After the experiment concluded, it was found that phytoplankton was the only bacteria tested that had survival limitations, while the rest could survive the harsh atmosphere of the solar system. The experiment also found oceanic impacts to be more survivable in comparison to land impacts. An alternative theory to directed panspermia is that the unintentional collisions of land may have also contributed to the spread of life on Earth. An experiment designed by astrobiologist Chandra Wickramasinghe took samples from the stratosphere with a high-altitude balloon and found viable but non-culturable bacteria. This could be potential evidence that comets or meteorites that pass by planets can deposit life forms or molecules onto the planet. If bacteria from the experiment came from interplanetary dust, then the theory of interplanetary panspermia can be argued. Interplanetary panspermia suggests that meteorites coming from a different planet carry biological material that may have caused the beginning of life on Earth. In 1996, a 4 billion-year-old meteorite originating from Mars was found to contain microscopic structures resembling bacteria found here on Earth. This not only supports the theory that there could be life on Mars, but that it could also be transported to other planets. The theory of cometary panspermia is supported by the evidence of the Murchison meteorite. This theory of panspermia proposes that comets serve as the transportation mechanism of life forms throughout the universe. The Murchison meteorite was shown to contain 74 amino acids, which are compounds that play a crucial role in all biological processes here on Earth. The meteorite also contains biological structures similar to the ones found on Earth, such as the ones found in the flu virus. Now that you know more about panspermia, let's talk about how we can attempt to use this idea for our own purposes. As David Tepfer says, pursuing panspermia would surely be simpler than fixing the problems here on Earth. The methods we could try, as suggested by David Tepfer, include small packets of bacteria propelled by solar sails. Plant seeds could be sent to distant targets as they have been proven to survive the harsh conditions of outer space. A larger number of seeds attached to space probes. Biological material in a transport mechanism could be boosted towards the target destination with a timed explosion. Biological material should have additional UV protection in order to shield them from the harmful rays of the sun. In our opinion, future technologies, evidence, and experiments needed to further prove panspermia would be the testing of ancient bacteria to see if they're similar to extraterrestrial bacteria. Considering that the bacteria would have been fossilized, we can't test the DNA, so we need newer ways to test the bacteria in order to find similarities. If we find features specific to extraterrestrial bacteria, and find that they are also present in the ancient bacteria, that could be evidence that they are linked. The bacteria we have now would have evolved to fit the conditions we have here on Earth. Could our origin really be from another planet? Were we placed here by an alien civilization? As more evidence is being discovered, scientists are getting closer and closer to answering these questions.